Well, hello there, and welcome to the Sky Guide for September 2021 as we slide into autumn. Now then, there's loads and loads of activity on the sun here. Actually, a whole new group of sunspots. We've got 2863 has appeared now, and it's more or less facing us. And another double group there, 2864 and 2865 up the top. New groups coming in here, 2866. And a new one appeared on the western limb there, 2867. So there's lots and lots of solar activity. And actually, as we look here at the stats, we've dropped from last year's 57% of days were spotless to only 22% so far this year. So in 2021, solar cycle 25 is getting well ahead. Looking at where we were 10 years ago, that was 14% in 2010. So we're getting back towards that sort of period in the 24th cycle. 25 actually seems to be getting off to a very lively start. There was nothing like this in 2010. So we're very optimistic that this will be a better cycle than we thought. Initial predictions were sort of saying similar to solar cycle 24. Now people are beginning to think a little bit more. And this is actually the range of the predictions. This would be the original prediction that said that 25 would be very similar to 24 there, but now there's other. That's what the average was since 1755. But this is what they're really thinking now for some newer predictions for solar cycle 25, and it's looking very good, even bigger, possibly, maybe, than solar cycle 23, which was a bit of a belter. There were some great auroras came off that one. So very optimistic for solar cycle 25. We're also coming up to the right time of the year to be looking at auroras because there is this phenomenon called the Russell-McPherron effect. And what that's really saying is that if you look at December and June, the Earth's poles are not aligned with the sun. They're tilted away in the case of the December solstice, or towards in the case of the June solstice. But actually at the equinoxes in March and September, it just makes this easier for the Earth's magnetic field to suck in the solar wind and sort of result in activation of the auroral glow. So that's really what's going on there with the Russell-McPherron effect, which makes around September and March is a really good time to be looking for auroras, and it's quite a broad peak as well. So any time from the beginning of September up into October is pretty good. So that's what we're looking at there. Here's just an illustration of the difference that the solar peak makes. Now this was one of the first, I think this was the first auroral picture I got in cycle 24, not until October 2012. And you see it's a fairly sort of bland green, what we call a ground hugger. It doesn't get much above the horizon at all, and not much red really going on there, not many beams, in fact no visible beams in that. Compare and contrast with April 2016, 3.5 years later, at the peak of cycle 24, and we've got these wonderful beams going sort of 20-30 degrees up into the sky, and a lovely, much more bright green auroral oval. And both of those were taken from the same place in Ballygally in County Antrim, just at different parts of the solar cycle. Now then, have we got any yet? So, well, yes, we have, because Alistair Hamill, my friend, Northern Irish photographer, he was up at the Giant's Causeway here just a week or so ago, and got these red beams here. Red is generally caused by the solar wind interacting with oxygen atoms in the atmosphere to create the nice red colour, and he's really got the first beginnings of the cycle 25 auroras there, and so well done, Alistair, for capturing that. It's a great job. Now then, in terms of the moon phases for September, well, the moon is new on the 7th, First quarter was on the 13th. It's full around the 20th, which is slightly unfortunate because that means we do have a big bright moon around the time of the equinox, but not so good. But it's a broad peak, so it doesn't really matter so much there. The last quarter is on the 29th, and then the moon goes out of it again into the beginning of October. So that's probably a good time to be looking for the aurora, just around the turn of the month. The equinox this year actually is on Wednesday the 22nd. It can be the 23rd, depending on leap years and stuff like that. But it's 22:09, 21, 21. That's British summertime. At 8 o'clock in the evening is the exact instant at which the North Pole is at right angles to the direction of the sun. So that's the moon phases and the equinox. Now then, planets. Jupiter is a bit past opposition, which means it's not quite its biggest and brightest anymore, but it does mean you get a chance to see it a bit earlier in the evening. So in the south, in the constellation Aquarius, about 20 degrees at around midnight is a good sort of time to be looking for that. Likewise, Saturn is in the same part of the sky, and that's just about 18 degrees to the west of Jupiter, and that's a little bit further past its opposition, but still looking quite good, albeit a bit low. We're not seeing Mars this month. Mars is round the other side of the sun. Venus, you might be if you're very lucky. It's a difficult catch. The angle of the ecliptic is such that we may not see Venus easily. Likewise, Mercury could be visible in the morning, only it's very, very hard to actually see. But Uranus and Neptune, you'll see those. They're quite well placed now. Later in the evening, close, and they get better as the month goes on. Uranus is magnitude 5.8. Neptune, visible in Aquarius, about magnitude 7.8. So Uranus can be, if you've got really, really good eyesight and a good sky, Uranus can be seen naked eye. Neptune, I'm afraid, cannot. You need at least a pair of binoculars, bright binoculars, 10 by 50 or 15 by 70, or a small telescope. And I'm afraid that all you will see of Uranus or Neptune with amateur equipment would be Uranus appears as a green blob, Neptune appears as a small blue blob. Although in fact they are very big ice giant planets, it's just they're a long way away. Now then, let's have a look at that part of the sky that you need to be looking to see the planets. Now this is south. This is 14th of September, middle of the month, local midnight, British summertime. And looking south, we see Saturn and Jupiter, both actually by that point in Capricorn. Jupiter does move from Aquarius to Capricorn early in the month. And then we've got those two there. Now we find Neptune is the hardest one to find. But I would start looking at the great square of Pegasus and then follow that downwards until you reach the line of the ecliptic marked out by following on from Saturn and Jupiter. Similar sort of distance as the gap between them, and perhaps a bit longer, and where that intersects with being below the right side of the great square of Pegasus, that's the region of the sky you need to be looking for Neptune. And if you get a star map and zoom in closer to that, you can work out which of the various stars of 8th magnitude or so is actually Neptune there. But it is quite a distinctive blue colour, so it's quite easy to find like that. Uranus is in a not hugely populated part of the sky below the two main stars of Aries, Hamal and Sheraton, and looks sort of about 10 degrees down to the southeast from Hamal. And you'll find Uranus is a small green blob in that area. Now then, let's take this as our starting point for a tour around the dark skies. We're looking here at the great square of Pegasus. It's a great place to start. And one of the things that we can see very easily during September, it's a really good time to be looking for it, is our nearest main galaxy, the great Andromeda galaxy, Messier 31. And how we find it is this. We find the great square of Pegasus. Those four stars are fairly obvious in the south there, actually southeast. And what we do is we memorize in our own minds the distance between the top two stars there. Of the great square of Pegasus, and then we go to the top left star, Alpheratz, which is actually in Andromeda, and we memorize that distance and take a slight right turn and go to the next star we come to, which is that one there, Merak in Andromeda. And we zoom in a bit. We take a sharp right turn then and go to the first star we come to, which is this one here, which is Mu Andromeda. And then we go the same distance again until we come to a fuzzy patch in the sky. And looked at through binoculars, that's what it will be, is a fuzzy patch in the sky. And likewise, actually, through even some quite good telescopes, that's what you'll see. But when you start getting cameras on it and collecting long exposures, then you can actually see a lot of detail in that, the spiral arms and so on. And here's the thing about the Andromeda Galaxy that people probably don't realize quite so much, and that's how big it is. If you think that the sun and the moon are half a degree across in the sky, actually, you take a measurement of the size of the Andromeda Galaxy, and you'll find it's about 3 degrees across there, and so that's 6 moon widths or 6 sun widths, which is really rather big. And if it was brighter, it would be absolutely fantastic in our skies. It will, of course, over billions of years become bigger and brighter because it is moving towards us. And indeed, our Milky Way galaxy and M31 will collide at some point in the very far distant future. I think that we will either have gone somewhere else or be a far distant memory by that time. But that's the Andromeda Galaxy. Now then, if we head over towards the other side of the sky here, now that you can still see the summer triangle here. The 3 bright stars, quite high up still. Deneb in Cygnus there. Vega in Lyra, and Altair in Aquila, the eagle. And 2 of those stars are actually really quite near to us. Vega is about 22 light years away, and Altair is about 16 light years away. But by contrast, Deneb is a very long distance away. It is a huge celestial searchlight. Although it's the least bright of those 3 stars, actually in reality it's much brighter than either of the other 2. It's just so far away, 2,500 light years or so, and doesn't give us a distance there. But it is actually, in terms of absolute magnitude, it's about -7. It's huge. So that's the summer triangle. Now, there's an awful lot of stuff of interest in that general area. We'll start off at Deneb and head in there and just have a look. 2 degrees to the east of Deneb, we have here the North America Nebula. It's a sort of hydrogen alpha emitting region, and you can see why I call it the North American Nebula. You've got Mexico here, the Gulf of Mexico there, Florida down there, and Canada all up the top here, California down the west there. And next to that you have the Pelican, and you can see the beak and the head of the Pelican there. So that's that shows up if you've got a camera that's reasonably sensitive to hydrogen alpha. A lot of modern cameras filter all that out because infrared that sort of messes up autofocus and stuff. But some cameras let a fair bit through, and if you've got enough red light coming through, you can also get modified cameras that just let everything through. Then you can get nice photographs of the North American Nebula. So coming across to Vega. Here we are. Here's Vega, bright blue star. Not all that bright really, because it's just the fact that it's near. Here's something nearby there, the double Epsilon Lyra. Now let's go have a look at Epsilon Lyra. It's the ultimate double star really, because there you can see that beautifully. As a small telescope will show that, or even binoculars will show that as double, because it is 5th magnitude. Each part of it is magnitude 5.2. But actually, what you need a telescope for, you need magnification more than light gathering. I've seen this in a 4-inch Maksutov Cassegrain. You go right in, and you'll see that each double is itself a close double star. There we are. That's the double 2. And we come out of this, and the double 1. We go have a look here, and we can see that also is a close double star, and that's the double in Lyra, Epsilon Lyra. While we're in that neck of the woods, let's go and have a look down here. Now we have there we are. This is a nice one, telescopic object only. Looks great in a 10-inch Dobsonian or an 8 even. something like that. This is the Ring Nebula, Messier 57. And the thing to get here, if you've got your scope perfectly focused and it's collecting a good light, there's a star right in the middle of that planetary nebula of about magnitude 14, 15. But it is possible to capture that again on a camera or indeed naked eye if you have a big scope. So that's Messier 57. Now then, let's have a look while we're here also down at Altair, and we'll go down to Altair. And Altair, you see, is actually right in the middle of the Milky Way, and September is a good time for going fairly well southwards on the Milky Way. You can go down into the clouds of Scutum here. That's all looking fairly spectacular at this stage. Further south in Ireland, you can go a bit further than that as well, but that's pretty much it for us in the north. A bit earlier in the year, August, you could have got down to Messier 22, which is a globular that's even a bit brighter than Messier 13. We'll look at that in a minute. But that's what you could see there. The Milky Way, really, to see it at its best, you need to go to more equatorial latitudes or even into the southern hemisphere, where you're actually looking much more into the centre of the galaxy and you get a better view there. But September is a good time for the Milky Way down below Altair there. Coming back up to here, my favourite, everybody's favourite double star, of course, Albireo, is Beta Cygni, on the bottom, right on the bottom end of Cygnus there, again in the Milky Way, in the Cygnus Rift, just to the west of the Cygnus Rift, and we can zoom into Albireo. We can see that that's a beautiful double star, visible quite easily in a small telescope, and the larger, brighter component is a sort of sapphire gold colour. A gold colour, not a sapphire, and the blue component, that is a sort of sapphire blue colour. So there we are, gold and sapphire in one star. That's really good, and they are really, that's not a line of sight thing, they really are a binary pair, gravitationally bound to each other. Okay, so one other thing we'll look at before we pass on our interest in this night sky is we go over into Hercules here, and here we go, and just down here we have Messier 13, the great globular cluster, Messier 13. It is the biggest and brightest one, easily visible in the northern hemisphere. So Messier 22 is technically a bit brighter, but that is a full of stars globular cluster on the outer edges of our own galaxy. And it looks absolutely superb through a telescope. Again, if you want to really see globular clusters, the southern hemisphere is the place to be, with Omega Centauri and 47 Tucani available, both much bigger and brighter than our M13. But this is what we've got, and it does look pretty good. So that's really a quick guide around some deep sky objects to see in September, and we'll be back with more in October. So that's all I have to say for September, other than stay safe, keep looking up, and thanks for watching.